What is going on? Today is March 28th, Sunday, end of the week, beginning of a new week, end of the old week. And I'm going to take you on, you guessed it, another journey through the wonderful world of algorithms. So I am going to tonight do a different kind of problem. I've been doing a lot of tree problems, and as I said before, I love tree problems. So today I'm going to tackle a common problem in the world of algorithms, but it's a well-known CS problem, but it's a little different because there's a different data structure involved in it, and it'll be group anagrams. Problem 49 on Leetcode. Seeing as Leetcode has thousands of problems now, this is one of the early Leetcode problems. And as you can see, the ratio of likes, 5,100 to 227 dislikes. So it's over time been a well-liked problem, and probably a problem that appears quite often on interviews. What can I say? So, by the way, before I begin, if you like this video, please like, subscribe, and hit the comments below. Leave me some feedback. Any feedback helps. I know you can probably find a lot of the solutions to these problems everywhere online, but I wanted to kind of bring my own take and explanations. I hope they help with people understanding how the coding works, and I hope I can be clear and provide a friendly voice into the world of algorithms for you and problem solving. And without further ado, group anagrams. So, given an array of strings, strs, group the anagrams together, you can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So, just let's say your input is your strings eat, tea, tan, ate, nat, bat. So remember, an anagram is pretty much, it's a string that has a pair of words are anagrams. If all of the characters in one string are the same and in the same number as all the characters in another string. So eat and tea are anagrams. Tea and tan are not anagrams because they differ by the A and the N. The E and the A and the E and the A differ. There's no E in tan, and the N. Well, there is an A. There's no E, and also the N. There's no N in tan. Okay, so there's a few ways, and then so the solution is, before I get to the ways to solve the problem, the solution is that you have three distinct sublists of this super list, right? And all the members of each sublist are anagrams, are the same anagram. So there's three anagrams in this list: ate, eat, and tea from the original list. Eat, tea, and ate. These are the three anagrams from the original list in this group. And bat is the only word that has any letters in common with any other word other than itself, so it is the only member of the first list, and nat and tan are anagrams of each other, so they're in the second list. So there are several ways to solve this problem, and I'm going to go through probably what I believe to be, it's not actually going to be that fast of a way, but I hope it'll be a clearer way to solve it. And also it's sometimes when you do data structures, you obviously want the most efficient method, but sometimes you can do some interesting stuff with data structures that are not commonly used to solve a problem, but they're good at explaining what's going on in the problem. So what's the fundamental gist of this problem, right? All these words have to have the same letter count, okay? So that should be easy, right? Because when you think count, when you think number of letters, right? And when you think looking up stuff fast, right? You want to use, naturally, if you've been practicing algorithms for a while, you would want to use, or at least it should come to your mind that you should use a hash map. So a hash map is a data structure which has quick constant time, amortized constant time lookup for any of the elements in that map. So there's lots of good videos on hash maps. I may point to some here, but I'm sure if you've gotten this far during the course of my videos that you're pretty familiar with how a hash map works. So no need to worry, and no need to go too far down that route. Or no need to go too much into the details more than that. And so let's get to coding. So how would I code this? So let's talk about the overall procedure. I'm thinking what I should do is basically generate a bunch of maps, right? A map for each word. and then I need a map of maps to quickly determine membership. All right, so a map of maps where the values are lists to determine membership of a word to a particular anagram set, right? So this is it's easier to actually demonstrate by coding. So first thing I'm going to do is hash map, and again you're going to see that this isn't the most efficient solution, but it's a solution that I think has a little bit of uh, cleverness. Well, I don't know. Whatever you think. I think it's clarity is maybe the word. And map. So this new hash map. So this is my core hash map data structure. Okay. Um, Now I want to have my final results. My results is a list of lists. Okay. So string result equals new array list. Okay. Okay, so this is what I'm going to end up returning, so I'm going to return the result. So I want to now iterate through each of my strings, right? Because we want to determine the membership of each of the strings, right? I'm going to call strings, and I'm going to iterate in this membership for loop like this. So what am I going to do here? Okay, so the first thing I want to do, right, is I want to determine whether I want to determine membership of a map into the larger map, right? So what would I need to do there? In order to do that, first I need to actually determine the counts to see if membership is even if membership can be established for a particular string into an anagram group. Okay, so I'm going to actually create a function that generates hash maps, integer keyify. Okay, string. Okay, so what is keyify? Keyify generates a map, and remember the map is what I'm going to use as the key into my master map, right? My little string map. Okay, so how would I do that? I could do this like this: character integer map equals new hash map, or int equals I 0, I less than dot length. Okay, and I plus plus. Okay, so now I'm iterating through each of the characters of my string, right? Because I want to determine the total char count, right? So char c equals char at I. So this is basically me saving this character to a string, the string to a character variable, and then map dot put c map dot get or default c0 plus 1. So this is a little neat shorthand for those who aren't familiar. The get or default method, that um, that is it was introduced in Java 7, I believe, for maps, and it lets you get a default value if the map is null. And so what I'm saying here is that if I'm going to always try to put something into my character map, and if the default value is not already there, before Java 7, what would happen was get or default didn't exist. So if you tried to get a non-existent member, you'd get a null pointer exception. So instead of getting a null pointer exception, if C doesn't exist in the map, I add a 0 here. I put the default as a 0, so it'll be set to 0 and then plus 1, because by the time I get to this iteration, I have at least one iteration of C, and otherwise I'll get the default value of C if there is C already in the map. So if it was 1 before, then it will become 2, and so forth and so on. So then the character count will increase accordingly. Okay, so that was the quick setup for that. So that should return my map. I could actually call it key, but whatever, you know. So now here comes the meat of the program. Character integer key equals keyify string. Okay, So basically, I created a key from the string, as I said I was going to do before. And now, if anamap contains key, let's see, let's make sure that this is right. If anamap contains key, so I'm checking if the key, the hash map, is in my current master anagram map. Get key add string. So if the map is, if the anagram map contains this key, then we're just simply adding it to the master list, right? Because at some point, this anagram group was discovered from our iteration. But if not, right, then in that case, we'll create a new anagram group, and a group equals new array list string, and ana group dot add string and ana map dot put for my key. Remember, my key is a hash map, and that hash map will index an O of 1 time into my master map. Okay, and that's why I did this, because I could so I could quickly access any of my anagram groups through the hash map. Now, there's something a little peculiar here. I may get into it in a bit, but we'll pass for now. I want to get through this algorithm. So now, all I'm doing is adding this to my final list, my list of lists, right? Because the list of lists is a data structure that is cared about here, right? You know, it would be nice if we had a hash map returned, but that's not what it is. So we'll have to spend that extra time running that. And look at that, bang, accepted. Okay. Now let's try running then the entire thing in 1 millisecond. And bam, accepted. But wow, it is just on the edge of acceptance. Faster than 5.09% of Java Online submissions, memory usage 46, only better than 13.46. So obviously we could have done a lot better. And there's other ways to solve this problem. One way is that you can take advantage of sorting to determine membership first beforehand. So the sorting of the strings, because think about it, if the key is sorted, then it's always, every key once it's sorted, every string once it's sorted is going to immediately be able to index into some sort of map structure, because for example, if you have TE8 and ATE, both of those are going to turn immediately to AET, right, slash AET, and they will be immediately determined as anagrams. They'll automatically be part of that group. So obviously we could have made this more efficient. I just wanted to do something quick to kind of get the motivation running and play around with maps or whatnot. So again, if you like this video, subscribe, click on the link below, add comments, add feedback, and I'm open to any suggestions. And with that being said, have a great night, and looking forward to seeing you coding some more. All right.